Okay. Let's see who's here. Hi, can you hear me? It says no one's watching this, so. Okay, thank you. I'm just gonna wait a little bit. How are you guys? How are you feeling about the AP? Okay. How are you feeling about the AP? There's probably a delay. And also let me know what you feel more comfortable with, the multiple choice or the FRQs. I will share my screen in a minute, so don't worry. Yeah, most people are. I'm nervous about my APs too, but don't worry, you got this. We will help you feel less nervous. Let me just make sure this is going well. Okay, cool. Yeah, Unit 8, practice multiple choice. That's good, at least you're doing it. You started practicing. If your teacher finished the curriculum, you're very lucky because a lot of teachers are struggling to finish. Yeah, Unit 8 is a lot. But if you break it down, I recommend Boltzmann Science and Organic Chemistry Tutor. They have really good videos. Wes also has good videos I can send you guys on his YouTube that he made for students last year during quarantine. Yeah, finishing the curriculum is really difficult. In my school, they pushed it back to Admin 2, so they're taking it like May 25th so that the teacher can finish the curriculum. It's like really hard to finish. Which chapter is 17? Okay, June is good. You have time. I'm figuring out how to share my screen. Okay, let me know what you see. Do you see the Jamboard? Oh, Entropy. Okay, Entropy is the last lecture count, so you guys are in a good place. At least you get a lot of practice, even though your teacher did rush. Yeah, Entropy is the last unit. Do you guys want a breakdown? Like a unit breakdown? I can definitely get that for you right now. Here, let me get that. I will put together. Okay, second round, you're fine then. Here is the breakdown. That is a quick breakdown though. Let me get a more in-depth one really quick. Let's see. This is the really long one. I'll send right here. The first one should give you a good idea of like topics you should study. You can put them in a list and kind of go through them. Maybe as you do FRQs, I would personally try them once you studied a little bit and then make a T-chart, topics I know, topics I need more practice with, and fill it in as you go so you know where your strengths and weaknesses are. So I created a Padlet so it's easier for me to write. I will send you guys the link if you do want it. Here, I'll put it in the channel after too. You should be able to view it. Oh, that one says edit. Give me a minute. I don't know why that one says edit. It should be you. Well, it still says edit, but let me know if you can see, if you can open that up. I think you can. Yeah, it looks like 2 people are on. Okay. And do you guys have any, those of you that have a cram pass, do you have any questions from the last cram session? Because I know I wasn't able to be there. I think it was Unit 7, Equilibrium, but I'm not too sure. So I just want to make sure you guys are good with that. Okay, thank you. I'm just waiting if you have any questions. Does anyone have general questions as well? I want to answer before I do anything. I know there's a delay, so I like don't know how big the delay is. Okay. So if you do have any questions, just pop them in the chat. I'm gonna still having trouble with. Okay, you have breaks, so you have time. You can start practicing. Like this week, you can start studying. I'm gonna make a quick poll. I want you guys to fill it out really quick so I have a better idea. Oh, never mind. It's not a big enough poll. Okay, I haven't used Memory before, so non-SN bases. Okay. So the FRQs I'm gonna do today. They're a mix. I just chose the first 2 long FRQs and the first 2 short FRQs. Take a look at the first link I sent you, the at a glance. Aw, don't worry, you'll get an idea. Yeah, after acids and bases is entropy and applications of Unit 6, which was the heat unit. I'm trying to just remember. So yeah, I'm gonna go through the 2017 FRQs. So I put the link in here. I think you can copy and paste it. I'm not too sure. And if you guys do want to see the scoring guidelines, I did put the link just in case. I would definitely look at the scoring guidelines to see what the rubric is like. So after you finish a question, if you practice using these, which you definitely should, I would read the scoring guideline carefully and pay attention to the breakdown. So just so you guys are familiar, for the FRQ section, those taking the exam on paper, May 7th and May 25th. Oh, wait, let me see. You can't see what I'm doing. Here. Those taking the exam on paper, you guys have 7 total FRQs. The first 3 are long FRQs. They're 10 points each. And the breakdown is usually 23 minutes each. And then those taking it, and then the short FRQs, there are 4 of them, numbers 4 through 7. It always goes long to short, so that's not going to change. You should kind of know what you're going to see. And those are 4 points each, which is way less. And they're about 9 minutes each. If you're having trouble with one question, definitely skip it for a little and then go back to it later. Another thing about the FRQ section is that if you don't know a part of a question, so let's go here. See there's part A. Oh, wait, I'm not switching. See there's part A and then there's part B. If you don't know part A, you can skip part B and still get A completely right. Is it a time struggle? It depends. Like, I personally think you have a good amount of time. I think that it's manageable. I just think that you just have to read carefully, and practice, I think, will help more with time management. When you do these, once you do a few of them, start giving yourself a time limit. Give yourself 23 minutes, give yourself 9 minutes, just so you can see how you're doing with the time constraints that you'll have. So then those taking it digitally, yours is actually, your FRQ section is shorter. So I would focus on multiple choice strategies, and you only have 3 FRQs. One is long, 10 points, and the other is short. Well, they're 2 short ones. And the ones you showed us, I'll show you in a minute, don't worry. So the other FRQs, the other 4, are actually replaced with more multiple choice questions. So if you're taking the exam digitally, you'll have way more multiple choice. I have more details on the format if you would like that, but this is it for the FRQs. If you guys aren't familiar with Jamboard, you should be able to see every single page right here, and you can just go through them. So if you do scroll through, this is the first question on the 2017 exam. This is part A. You can see number 1 has part A, part B. Keep in mind there's even like subparts here. Part C with another two parts. Part D with 2 parts. I think that's it. Yeah, and that's it. But that was a lot. And then if you want to see the short ones, let's see. I'm gonna find short. This is the short one. That's it. I think that's it. Yep, that's it. This is a short one. There's a huge difference between them. So that's something to be familiar with before you take the exam. Let's go back. Does that answer your question? Okay. I think we should start. I'll show you guys what I do when I approach these questions. You can definitely have your own strategies. Try and figure out what works best for you, because everyone works differently. So let's see, they gave us carbon tetrachloride. It looks like they gave us the equation already. Can be synthesized according to the equation represented above. So we don't have to balance anything. We don't have to create an equation. We're all set. A chemist runs the reaction at a constant temperature of 120 degrees Celsius. So when you read FRQs, make sure you keep in mind you need this in Kelvin probably. You need to convert. So that's a temperature, and then you get a volume, 25 liters. Why is my writing thing not working? 1 second. 25 liters. And I automatically know that's a volume. So right now they already gave you temperature and volume. So chlorine gas, what they're talking about is right here, is initially present in the container at a pressure. Now they're giving us a pressure, and it's in ATMs. So that probably means we're all set. We don't have to convert. This is what I would kind of think about, because they do give you different units on purpose. So how many moles of Cl2 are in the container? So using this temperature, so what I would do first is I would list what we know. So we know it's 120 degrees Celsius. We know what's the temperature. We know the volume is 25 liters. And we know the pressure is 0.40 atm. And we need the moles. Does anyone recognize something we can use here that will help us get the moles using the given information? I just want to see. I can just go through them, but I feel like it's better if you guys think about it first, and then I'll continue. It's from the gas laws unit. Yep, ideal gas law. Good job. So this is PV. Technology is not liking me today. This is PV equals nRT. Yep, you guys all got it. Okay, PV equals nRT. So you can automatically plug in, except you need to convert this. So 120 Celsius plus 273, and that's what you plug in. That's Kelvin. I don't have the math actually, because I just plugged it in all in one equation. So we have the pressure, the volume. I would keep the zeros. You see I'm keeping the zeros. Equals the moles, which is what we need. The constant, I think is, yeah, I'm pretty sure, like 99% sure, is on your reference table. So if you do forget the units, look at your reference table. They wrote the units of R there, and the units of R tell you what the units of the pressure, volume, and temperature should be. So this is 0.08206. Then temperature is 120 plus 273 because we need to convert. Once you put that on your calculator, you divide. You should get around, again, technology does not like me, around 0.31 moles of Cl2. And that's the first part of part A. Before you move on, I would reread the question, make sure you answered it properly. So how many moles of Cl2 are in the container? We wrote that right here. We're done with this part. Part 2 is now asking us about carbon disulfide. Right here. How many grams? So now we have grams instead. We need to find grams. So we're probably going to use a gram formula mass or molar mass. How many grams are needed to react completely with Cl2? So this is where we use the mole ratio. You guys definitely have done it a million times. It's just stoic. So we need to find out how many grams of this are needed to react with what we just found, this mole amount. So 0.31 moles of Cl2, and we have to convert. So I use this method. So in this reaction, we need to get rid of this moles of chlorine unit. So we need something here. We need moles of chlorine down here. And in the reaction, we see it has a coefficient of 3. So that tells us there are 3 moles of chlorine. And at the same time, CS2 has a coefficient of 1, and that's what we're converting to. And if you were to stop here and get this amount, you would get points off because they're asking for a gram amount. That's why I said reread the question. You might just forget a step because you're trying to rush through the FRQs, you're trying to get it done, and you're nervous. So just make sure to read them through. So now we just convert it using the gram formula mass. Oh, wrong way. Sorry, we need to get rid of the top unit. So 1 mole of CS2. You want to look at the periodic table and add up carbon and 2 sulfurs, you get 76.2 grams, or around there. And this should give you, I'm pretty sure you guys are all familiar with this, but you multiply across the top and then divide the bottom numbers. And you get 7.9 grams of CS2. So now the question said how many grams? We have the gram amount. We finished part A. And these are our 2 answers. No, you do not have to show your calculation for molar mass because I don't think you do. I've never seen it on the rubric like that. Yeah, you would have to add the molar masses on the period. You have to add the atomic weight. Yeah, on the periodic table. I can show you guys if you want. I can pull it up. Let me know. But molar mass calculation, I'm pretty sure you don't need to do because they give you the values on the periodic table. All you have to do is add them. They want to see the chemistry part. Okay. Let me know if any other questions pop up. So that's part A. And I think this question had 4 parts, part D. So let's see. Now it looks like they're bringing in energy and kinetics. Oh yeah, I didn't bring in. They're bringing in energy and kinetics, and I know that right away because I see this graph, and I see this word collisions. And we know collisions have to do with how fast a reaction occurs and the amount of effective collisions. So just a quick reminder, in order to have effective collisions, you need to have enough kinetic energy, which is what this activation energy is, and the molecules need to be oriented properly. So those are the two requirements. That's called the collision theory. So let's actually read this question. At 30 degrees Celsius, the reaction is thermodynamically favorable. This is a Unit 9 concept, so you guys might not know it yet, but that basically means it occurs spontaneously. So delta G, which is Gibbs free energy, must be less than 0. It's negative. When delta G is negative, it's spontaneous. Thermodynamically favorable is a phrase they love. So if you have to write an explanation somewhere, use the phrase thermodynamically favorable instead of spontaneous, sorry. So the reaction is spontaneous, but no reaction is observed to occur. However, at 120, if you increase the temperature, the reaction occurs at an observable rate. So right away you should think, oh, it wasn't reaching its activation energy. So explain how the higher temperature affects the collision. My computer is like writing stuff everywhere. Affects the collisions between the reactant molecules so that the reaction occurs at an observable rate at 120 degrees Celsius. So this goes with, I don't know if you guys watch crams, but if you do watch crams, you know that temperature is the average kinetic energy. Your teachers all probably emphasize that. So that definitely has to do with this. So temperature, average kinetic energy. You gotta drill into your brain. So the higher the temperature, the greater the amount of kinetic energy. So let's establish that first. Oh my god, my computer. I will write that down in a second. Okay. So part 1. A higher temperature indicates that there is a greater, this is where we're comparing, average kinetic energy. I'm just going to abbreviate. So now we have to tie in how this concept of temperature relates to reactions. Yes, Haley, that is exactly it. So therefore, there are more collisions with enough energy. This is the collision theory. With enough energy to overcome the activation energy. That's a really solid explanation. So first you show that you know that temperature is average kinetic energy, and then you show that you understand the collision theory, which is, again, proper orientation. I just completely forgot the R. Orientation. And having enough kinetic energy. I'm just trying to say as much content as I can. I know that I'm not focused on the questions because I just want to remind you guys of some key points. That's it for part 1. I just wanted us to explain. So we're done with that. So now the graph below shows a distribution for the collision energies of reactant molecules at 120 degrees Celsius. Draw a second curve. So now we're drawing. Note that if you're taking the exam digitally, you don't have to draw. They're not going to ask you to draw. So draw a second curve on the graph that shows the distribution for collision energies of reactant molecules at 30 degrees Celsius. Then they want us to draw the graph of the reaction that didn't really occur because the energy wasn't high enough. The amount of energy there wasn't high enough. So this is something called the Maxwell-Boltzmann distribution. You've definitely seen this graph before. And this question, distribution, is kind of testing your knowledge of if you know this graph. You should know, I'll pull it up right here. I actually took a picture from the internet and pulled it in. Oh, this is a struggle. I'll put it over here. Ignore my words, but this is exactly what it's telling you. You have a cold temperature squished more to the left. You can see it stops right here, while the hottest temperature goes all the way to the end of the graph. So this kind of should just tell you the answer at this point. Yeah, you guys actually got it. Good job. Sorry, I didn't see the chat until now. So yeah, the graph would be narrower and shifted to the left. So something like, I cannot draw these. That. So I would remember from this question that a lower temp, exactly like you said, squish more to the left. And its activation energy is lower. You can see that right here, these 2 points. So something like that will suffice. All it wanted us to do is draw, so we're done with part B too. Okay. Again, let me know if you have any questions. So part C brings in unit 2. So if you notice, part A was stoich and gas laws, which is unit 3. Part B is collisions, which is unit 5. And this diagram, I'm actually not sure. Probably unit 5 too. I think it is unit 5. And now part C is unit 2. No, it doesn't. As long as it has that general shape and the activation energy has to be lower. I think the rubric has it so that as long as it's taller and to the left and lower activation energy. I think those are the 2 points. I think it's 2 points. But you can definitely take a look. It's on the scoring guidelines on the first page. So now we have this. S2Cl2 is a product of the reaction. In the box below, complete the Lewis electron dot diagram for the CSL. Wait, sorry, I'm reading chat at the same time, so it's blocking my reading. S2Cl2 molecule by drawing in all of its electron pairs. So it just wants us to draw a Lewis dot diagram. So if you're saying that if there is less temperature, there's less molecules that will, yeah. So if you're at a lower temperature, there will be less molecules that reach that higher activation energy. Because temperature has to do with energy. Temperature is the average kinetic energy. So I hope that kind of ties it in together. I would definitely try and make sure you understand this explanation like you're saying. Okay, so this question is all LDFs. And first thing with LDFs is just draw in single bonds. And then just draw the valence electrons. Make sure each has 8. So I just drew in the basic Lewis dot diagram. I don't know if it's right yet. Awesome. I'm glad you're analyzing it and making sure you got it. You really understand it. So now what we can do is check if it's correct. So chlorine has 7 valence electrons. Sulfur has 6 valence electrons. And we have 2 of each. So altogether, sorry, 1 sec. Altogether, we should have 26, I think it's writing again, 26 valence electrons is what I'm trying to say. Yeah, my computer is slow. Okay, 26 total. Does everyone see where I got that? I just multiplied each of these by 2 and added. because that's how many molecules are. So now we just check that there's 26. So we have, let's get my highlighter. We have this 8, because remember each bond is 2. We have this 8, so that's 16. And then this bond in the middle is 18. And then 20, 22, 24, and 26. So that means we already finished. They gave us a simple Lewis dot structure. We didn't have to do any double bonds, triple bonds, nothing to do with that. So now part 2, what is the approximate value of the chlorine sulfur bond angle? So it has to do with this group or this group, but probably this group because it's chlorine sulfur. It's in that order. What is the bond angle in the molecule that you drew? And then they just gave us a hint. So the reason why it's equal is because they're the same, if you look at it. It's a symmetrical molecule. So we don't have to worry about what they gave us here. We just have one angle. And this question is testing your knowledge of the VSEPR theory, which is something you have to kind of memorize. So I'm actually going to pull up in the chat right now something I created, and you might like it. You might have your own VSEPR chart that you are much more comfortable with, but I just want to put it out there. Let's see, where is it? VSEPR, okay. Oh, it's unit 2. Sorry, I'm looking at my own. Trying to pull up this guide for you guys. Cool, okay. So if you look in this guide, that I just put into chat. You are correct. So if you look at this in chat, you'll see kind of what I'm about to explain. So here, this molecule, like what we're looking at, it has an sp3 hybridization. So yeah, there are 4 electron domains. I don't know how your teacher does it, but to me, this means that it's family 4. You can definitely look at that guide I just sent. I would memorize the ones that are in the guide I just sent. So you have the 180 for the linear, you have 120 for trigonal planar, you have 109.5 for tetrahedral, and then you have several for family 5 and 6, because they're bigger. So knowing 4 electron domains, knowing that it's sp3, all that together should tell you that this is in the family of tetrahedral, and tetrahedral has 109.5 degree bond angles. So this is definitely memorization. Does anyone have any questions? We're done with part C. This part was a little bit quick. We just have to draw and write an angle. But if you do not memorize the VSEPR theory, which I recommend you kind of start doing, I would also memorize polyatomic ions, solubility rules. I think those are the main 3. So do we need to memorize for the 5th and 6th electron domains? I would memorize the shape name. I would know trigonal, bipyramidal, seesaw, T-shaped, linear, octahedral, square, pyramid, and planar. The thing you don't have to know, I'll tell you in a second. The thing you don't have to know is the hybridization. I'm not too sure if you have to know the angles, but I would just kind of know them to be sure. If you want a concrete answer, I would ask Wes, the AP Chem teacher. So what makes it sp3? The way I know the hybridization usually is I look at the amount of electron domains. Yeah, you got it. She explained it perfectly. So if we look at the central sulfur, we have this bond, which is 1 electron domain, this bond, which is 1, this bond, I mean, not the bond, the lone pair, and then this. We have 4 things branching out of the sulfur. So that's 4 electron domains. That's where this number comes from. If you have 4 electron domains, it's sp3. I always just know that by subtracting 1. That's why it's sp3, not sp4, which isn't even a thing. So yeah. Any other questions? So far we did Unit 5, Unit 3, and Unit 2. It's pretty good. It's only half a question. Well, almost the whole question. You're welcome. Okay, so let's take a look at Part D. So sp4, yeah, good job. So sp4 does not exist, as I said before. You do not have to know this, but for family 5 or for 5 electron domains, the hybridization is sp3d. Because, as you know from Unit 2, there are only 3 orbitals in the p, like in the levels. So S can have a maximum of 2 electrons, P can have a maximum of 6 electrons, D can have a maximum of 10, and then F has a maximum of 14. So yeah, it is sp3d, but you don't have to know that. That's why I don't want to mention it, just in case. Okay, so CCl4 can also be produced by reacting CHCl3 with Cl2 at 400 degrees. And they gave us the equation, which is really nice of them. If they don't give you the equation, just make sure you balance. So let's see. At the conclusion of the reaction, a chemist successfully separates the CCl4 from the HCl by cooling the mixture. So they did something to separate. And I'm not sure if you guys know, but the separation of mixtures aspect of AP Chem, it's kind of small, but there is filtration, there is distillation, there is something we'll see in the 4th question, or 3rd question actually, chromatography. There's one more, evaporation. So those are just the 4 main techniques to separate a mixture. So they cooled the products, and the products separated. 70 degrees Celsius is where CCl4 condenses while HCl is still a gas. So at 70 degrees Celsius, CCl4, I just wrote a capital L, that is not proper, CCl4 already condensed, but HCl is still a gas. So that tells you something about the boiling point. So identify all types of intermolecular forces, IMFs. This is Unit 3 again. Present in HCl. Okay. Does anyone want to give it a shot? It's a shorter question, so I feel like I should definitely ask. I'm just going to wait because of the delay. Okay, I don't know if you guys know. Yep, you got it. So the first thing I would note is that every single compound has LDFs. So if you ever get an IMFs question, oh, I didn't get your message in chat. So LDS is your answer always. It's just a matter of, do you have dipole-dipole, do you have hydrogen bonds, and all the other bonds, all the other IMFs. So here we have HCl. Chlorine has a high electronegativity, so it is a partial, I don't know how to make the sign, partial negative, and this is a partial positive. So therefore, there is a dipole-dipole. Because when you have 2 HCl's, this bond is not strong enough to be a hydrogen bond. Hydrogen bonds, H bonds, I'm just gonna make a quick note, occur between oxygen, sulfur, not sulfur, oh my god, oxygen, fluoride, fluorine, nitrogen, and hydrogen. So each of these pairs. So HCl only has LDFs and dipole-dipole. Part 2 is an explain question because they're asking what you can infer. I'll answer your question in 1 second. So what can be inferred about the relative strengths? So that definitely has to do with what I wrote over here. Because when you see strength, that means, sorry, I lost my train of thought. When you see strength, you should think of melting boiling points. So what can be inferred about the relative strengths of the IMFs in CCl, CCl4, and HCl? Justify your answer in terms of the info above. So you can't just list a random fact that you know. They want it to be within this context. If you don't do that, they will take points off. Yeah, it won't be ion dipole. That would be more with ion. It's like ion dipoles, you won't really see with IMF questions, in my opinion. The main three are LDFs, dipole-dipoles, and H-bonds. Dipole-dipole is the partial positive and partial negative ion dipole. They're much stronger. They're stronger than H-bonds, actually. So let me see what you said. So would we have access to the electronegativity charts? No, just like Seema said. Fluorine is the most electronegative. So for part 2, I'll read your explanation in a second. So we have to work with this info that I wrote on the side. And I wrote on the side because what they wrote is very wordy. So I might like skip over it later. So for part B, we have to think about the fact that CCl, yeah, wait a second. I'm looking at the wrong thing. Okay. CCl4 was easier to condense. It condensed first. Yeah, hydrogen bonds would not be here because there's no oxygen, fluorine, or nitrogen. So CCl4 was easier to condense. It condensed at 70 degrees Celsius. I'm trying to get my technology to work, sorry. It condensed at 70 degrees Celsius. Wait, let's see what you said. It condenses before HCl. It could be said that CCl4 has stronger IMFs, which is what causes it to go into the liquid form more easily. Okay. So yeah, CCl4 does have the stronger IMFs. I think that would work. I would just, yeah, I think that would work. If you guys heard it. If you see what they wrote in chat, you can definitely explain that way. So I have it written that this is just the main point. I'm not going to write the whole explanation. I have written that CCl4 has stronger IMFs because it was easier to condense. It condensed at 70. So that was the gist of that part. Honestly, I think your explanation is perfect. Since it is a polar substance. So you're saying you think it's more polar, right? So the reason why you can't explain that way is because they said this. They want you to think about the fact that it condensed first. That is the main reason. Because they don't expect you to really know which one's more polar. So yeah, I hope that kind of explains it. You have to do it in terms of the fact that it condensed first. Usually they try and give you these types of, these bits in the questions to guide you. They do that a lot actually, which is kind of nice. So yeah, and that was the end of this question. This question was 10 points. CCl4 only, I thought that CCl4 condenses before HCl since it has only, yeah, because it condensed first, it would have stronger IMF. So I'd use the word stronger instead of higher. CCl4 has, I think it has dipole-dipole as well. Oh yeah, it is nonpolar. You are right. I am confusing it. Okay, yeah. So they're explaining it perfectly. Thank you for helping out. I'm definitely out of it. It wouldn't work because HCl is polar, CCl4 is nonpolar. If you draw out CCl4, that is a highlighter. It's perfect symmetry. If you look at it vertically, it's symmetrical. If you look at it horizontally, it's symmetrical. The thing I remember is SNAP. So symmetrical, nonpolar, asymmetrical, polar. So this is symmetrical, so it is nonpolar. While HCl has a partial positive and negative. So it is polar. Okay. I know you guys had a lot of questions about that because IMFs are definitely one of the bigger units. They're one of the more confusing units. So yeah, I think this unit, unit 3, it has gas laws and IMFs, is 18 to 22% of the exam, but don't quote me on that. I think it's that. I'm not positive. So this is question 1. This whole thing was question 1. But I definitely did take more time than we needed because I tried to give you extra context to make sure you knew. So this is just a list of key facts. Heavener temperature equals average kinetic energy. This is honestly one of the biggest key facts. That is not a highlighter. That was really disappointing. There you go. It's not even gonna work now. Okay, so yeah, I would definitely know this. Memorize this. Drill it into your mind. Maxwell-Boltzmann Distribution. That's what one part was. VSEPR. Memorize VSEPR. That is a priority. And then IMFs, the largest unit. The stronger the IMFs, the higher the boiling point, the higher the melting point. D2. So what can be inferred, wait, I'm not even on the page, on your side. Okay, what can be inferred about the relative strengths of the intermolecular forces? It's just the fact that CCl4 condensed first, that it has stronger IMFs. That is just kind of something conceptual that comes out of this. The reason why you can't go polar, nonpolar route, you can't do any of that is because it says justify in terms of what we gave you. So any knowledge that you do know outside of this unit, outside of this topic really, you can't really use because they wrote that. It's kind of restricting, it's annoying, but this is really what they're looking for. I can even pull up, oh, I did not mean to cross that out. Oh, I can undo. I can pull up the scoring guidelines really quick. And we can read what they wrote if that would help. I think that would help, but let's go. I'm gonna pull it up right now. I am getting it. Okay, so let's see where we are. So yeah, CCl4 condenses at a higher temperature than HCl. Yeah, the scoring guidelines are on the first page of this. You can definitely go back and look, but I put it again in the chat. Let me stop sharing and switch my screen. Maybe chemistry scoring guidelines. Okay, so now you should see the scoring guidelines, I think. Yeah. So the first question just says dipole-dipole LDFs. Done. Second question, intermolecular forces among CCl4 must be stronger, which is what it's even asking, so you must say this part, than those among HCl because CCl4 condenses at a higher temperature. I don't know how to explain it further, to be honest. I think the West could explain it differently, because this is kind of how I learned it. So yeah, I hope that helps, the scoring guidelines. If you guys want, we can quickly take a look. This got way, okay. We can quickly take a look here at what the rest of the scoring guidelines were. So any value between 104 and 110, we had 109.5, which is what the tetrahedral family has. And then we get this, perfect. Here, to answer your question precisely, 1 point is earned so that it's above and to the left, like that. And 1 is earned so that the activation energy is under. Yeah, you have to look at the question, answer it based on the question. That's why they wrote that there. It sucks. They restrict you. They want to make sure you know specific things. Oh no, CCl4 does. Yeah, CCl4 condenses at 70. Because they're separating the mixture. Like, just in case, I want to do one more question. So definitely DM me. I will try and explain it further. I will get more resources as well because this question is a little bit strange. But I want you guys to see this as well with the Maxwell-Boltzmann diagram. And this said higher temperature is higher average kinetic energy, therefore there are more collisions. That's exactly what we wrote. And then here we just have some stoic. I will explain it to you further, don't worry. I just want to do one more question. Okay. Besides that one part, how is everyone feeling? I will try and make that more easy to understand. Okay, you should be able to see this again. This is question 2. We're not going to do it. It's really long. I can't do it in 7 minutes, but we can do it. We can do it next week if you guys want. If you like this, thank you for explaining it. If you like this, let me know. If it helped, let me know. I could do them every week. I can do them every Friday. So question 2, automatically we can see it has to do with formal charge. They tell you they want formal charge. They won't expect you to do formal charge unless they tell you. That's something you should know because that'll make you feel better about it. So this is formal charge. Part B looks like enthalpy. I'm glad. I'll try it. If you guys do want, I can do it more often. You're really good at explaining things. I love it. It helps me out because I'm like trying to do more. So this part has to do with bond association energy every weekend. Okay. This one has to do with delta S. So maybe I'll do this question next week. If you guys love it. If you guys want this more often. And this has to do with thermodynamic favorability again and the equilibrium constant. So again, questions will ask you specific things. Here they said justify in terms of delta G and K. 2 different units in one question. If you only answer 1/2, you don't get the full credit. That's why I want you to reread the question before you move on. Because what if you explain delta G and then forget about K because like you think you're done. So just always reread the question. This is also that question. This one is longer. It goes up to part F. Okay, so those are that. I will do that next week if you guys want. So this is a short FRQ. Maybe I can do it in 4 minutes because it's just chromatography, which is one of the ways. Let me get to that page on my writing platform. Okay, So this separates mixtures. It's one of those techniques. Yeah, I just have to find a reliable source of multiple choice questions before I do them with you guys, because I definitely want the ones that I do with you to represent AP questions. But that is obviously hard since there are no released multiple choice questions. I'm going to ask Wes about that too, and I'll get a better idea and hopefully do some multiple choice. Okay, so chromatography separates mixtures. A student investigates various dyes using paper chromatography. The student has samples of 3 pure dyes labeled A, B, and C. The student prepares the chromatography chambers shown above on the left by putting a drop of each dye, as indicated, in their position on the paper, which is a polar material, but it's in a non-polar solvent. That part is something really important in this question. When you see chromatography, you should think like dissolves, like polar substances dissolve polar solvents, and non-polar substances dissolve non-polar solutes. Don't they usually include some in the CET? Oh, you're right. Thank you. Okay, I'm gonna write that down. CET, multiple choice. I will definitely look at that. We can do this. You're right. They do give like sample questions. So like dissolves like is going to be important because nonpolars, we know it's a nonpolar solvent. So we should know from here that the one that traveled the furthest is the most nonpolar because they're similar. So which dye, A, B, or C, is the least polar? This annoys me because instead of writing is the most nonpolar, they wrote least polar. So this means most nonpolar. Justify your answer in terms of, again, the interactions between the dye and the solvent or between the dyes and the paper. So there are 2 different ways you can explain this, hence the or. You don't have to do both. There's no and. So I definitely pay attention to that. So for this question, it has to do with like dissolves like. My technology is broken again, so I'm going to refresh. Yep, you are correct. C is the least polar. So you know how I wrote most nonpolar? In your answer, rewrite what they said. I am dying with my technology. Okay, that was really sloppy. So C is the least polar because they want us to explain in terms of interactions, because it was attracted most I'll answer your question in a second. It was attracted most to, now it's not letting me write again, to the nonpolar solvent. Yeah, okay. I don't know if you guys want this definition. I have it written down. More specifically, chromatography is the physical separation by attraction. This has to do with solvent-solute interactions to a solvent. So the mobile phase, I'm pretty sure the mobile phase is the dye, because it's the thing that's moving. The stationary is the paper, which is in a nonpolar solvent. So really quick, I know it's 7 in Eastern time zone, but part B, Which dye is present in the unknown sample? So they gave us this paper. So this is what we know, the size, this paper. And this is what we have here, and it's unknown. So this dot traveled halfway through this paper. C did not, so it can't be C. It can't be B. It's actually A. Because it traveled halfway through the paper as well. It travels as quickly as dye A does. So A, now I can't write my thing again. Okay, A is most likely the unknown sample because, like the unknown, it travels halfway up the solvent front. And that's question 4. It's done. That's it. Compared to question 1, this one was a piece of cake in terms of length. Would it be beneficial to add the phrase like dissolves, like attracts like? So you can say it, it won't take any points off, but I personally would explain it and say that a nonpolar substance will dissolve in a nonpolar solvent. Something like that. I would put it into chemistry terms, but you can definitely write it down. Because it does show you understand. So that is it for number 4. Halfway up the, yeah, you can definitely say that. Because that does indicate, again, that you know the size of the paper changed, and that means both have to be halfway. Yeah, so this is the 2017 FRQ section. I only did 2 questions though, there are 7. So if you like these questions, if you feel comfortable with them, that means you'll probably feel almost comfortable with the ones you'll actually see, because you don't always know what's going to show up. But this is real FRQ. These are real FRQ questions. Oh my god. They're definitely harder units. Like, some questions are going to be acid base, and I know that's the hardest unit, at least in my opinion. I think in your opinion as well. So those vary. Like unit question 5 has to do with combustion. And this, spoiler, has to do with Q equals MC delta T. I can see that because it has mass, initial temp, final temp, specific heat. That should signal right away Q equals MC delta T. I think that's it. Yeah, and this is it's only 3 parts, this short question. So everything varies, but that's the gist of it. Yeah, acid bases are awful. But once you get into it and you finish a really difficult question, you're like, wow, that was good. Like, you'll feel proud of yourself. If there have any other questions before we head off, sorry, this is a little bit longer. I did want to finish that question. Okay, I don't see any questions showing up. So if you do end up having questions, you guys can look at this Padlet at any time. You can save the link, the Jamboard. I'll put it in the Discord channel as well. It's always going to be here. You'll always be able to view it. You'll be able to switch through the pages, and it's there for you. Another reminder, if you guys have cramp pass, Sunday is a cramp session. I'm not too sure if I can be there this week again, which is really unfortunate, but Sundays are a little bit more difficult for me. But I would definitely trying to figure that out, actually. Okay, cool. So I see there are no questions in the chat. I hope you guys have a great weekend. If you have any questions, let me know. I will try and do these every Friday, maybe. Of course. Have a great weekend, everyone.